Okay, so in class today you should have completed your foldable with a graph that had examples of relative and absolute maxes and mins, increasing, decreasing, x-intercepts, and then you should have reviewed some key concepts just like these on pages 43 and 44. So now on page 45, in case you didn't get to this in class, or in case you need a refresher, we're going to go over page 45, and I just want you to take note of the title. It says a great test-like problem. Hint, hint, wink, wink. Something like this is probably going to show up on your test. So I've taken a picture of the graph on page 45, and we're just going to go through and answer the questions. So question number 1 wants you to answer what is the value of t where h of t equals 4. So what this is saying, h of t is like y, so where does y equal 4? So we're going to go over to our graph, and we're going to draw a horizontal line where y equals 4. And then we're going to write down the x values, or the t values in our case. So in our case, t is going to equal 2 and 7. Please note that we don't include the 3 because there's an open circle there, so it's not included. Question number 2. It says I want you to find h of 3. Well, this 3 is an x value, so I'm going to go up or down to the graph until I touch 3. Again, we have an open circle, so we don't include that first one, but we're going to use the second one, and when when t or x is 3, then my h or my y value is 5. So the answer to number 2 is simply 5. Number 3. Number 3 says, find the coordinates, if any, where h of t is an absolute maximum value. To be an absolute, it is the highest point the graph touches. Well, we have one of those. It's right here. Right here. Right there. That's the absolute highest point I touch. So my absolute maximum is going to be 5, 6. And just a little note about this one. If it says, what is the maximum value, the answer would have been 6. If it asked where the maximum occurred, the answer would have been 5. And since this problem said, what are the coordinates, we're going to actually give the ordered pairs 5, 6. Number 4, which I'm going to do down here, a little bit longer, it wants to do increasing, decreasing, constant. So I'm just going to go along the graph and list my intervals. Keep in mind, at the very end points, you are not increasing or decreasing, so those always go at the constant column. And we're always going to use parentheses for this. So I'm going to start at the end of the graph at -7. So from -7 all the way to 1, I decrease. So from -7 to 1, I decrease. And then I jump, and from 1 to 3, 1 to 3, I'm going to increase. 1 to 3, I increase. And then if you look at your graph, from 1 to 3, you increase. And not only from 1 to 3, you increase, but you actually continue to increase from 3 to 6. Nope, sorry, I think that's a 5. From 3 till 5. Let me fix that. Cross it off. From 3 to 5. And then once you get to 5, you're going to be a constant. And then from 5 all the way to 9, we're going to decrease again. So we're going to put our little u and go from 5 to 9. And so if you're going to note, all the little endpoints are going to be where I'm constant. So I'm constant at x equals -7, 1, 3, 5, and 9. Okay, I had to add a new page because I ran out of space. Number 5 wants you to state the domain. So my domain for this graph is, I start at -7, and if you move along your x-axis, I start, different color, start right here at -7, and then I move along my x-axis At 1, I touch, I keep going. At 3, I touch, keep going all the way until I get to 9. So my domain is going to be from bracket, because I touch -7, comma, 9, and I'm also going to have another bracket there. My range is from top to bottom. So I'm going to do a similar idea. The lowest place that I start and I actually touch is -2. And I go all the way up till 6 and I touch it. In any place where I'm discontinuous. Well, discontinuous would be something that was omitted or jumped over. And even though there are holes in this graph, other pieces of the graph fill it in. So like if you look at 2 for a second. Sorry, at x equals 1. Right here. At x equals 1, I have an open circle. But if you go down right here, that circle closes it up. So I don't have any points of discontinuity on this graph. Number 6 wants you to find the absolute minimum, the lowest. What is the absolute minimum for each of t? So the minimum that this graph touches is -2. It didn't ask where it occurred at, it asked what it was. What is the minimum value? Well, the minimum or the lowest point I touch is -2. Number 7 says, at what value of t does the absolute minimum occur for h of t plus 2? Well, I just want to talk about this for a second. This is a good problem. So I have this new function h of t, and it takes my, I have f of t as my new function. It takes my h function, and it does t plus 2 to it. Well, this requires you to remember your transformations. That plus 2 is going to move it to the left 2. So if my absolute minimum was at it was at -2, but the x value was 9, so it occurred at 9 comma -2, and the graph moves to the left, then the answer for this problem is going to be 7, because if you're at 9 and you move to the left 2, the answer is 7. And then it says for number 8, what is the absolute minimum value for q of t, which is some new function that took my h of t and moved it up 2? So if my minimum was at -2 and I moved up 2, then my new minimum is going to be at 0. You need to take note what the question is asking you. So let's compare 7 and 8 for a second. 7 clearly says at what value of t, so I gave a t value or an x value. But number 8 says what is the minimum value? It's talking about the high and the low. What is the minimum? Well, my minimum, my low value was -2. I moved up 2. -2 plus 2 is 0. And then 9 and 10 want you to write equations of lines. So let's go ahead and do that. So for number 9, it tells me that from -7 to 1, I'm linear, and it wants me to write equation of that part of the graph. So we know our y-intercept, if I were to do, I'm number 7 down here. We know our y-intercept, or our b value, is going to be equal to 1, and we can count our slope on this. From this little dot I'm breaking to this little dot, we know that it goes up 1 and to the left 1, 2, 3. So we know our m value is 1 over -3. So if I wanted to write my equation, y equals -1/3 x plus 1. I'm so sorry, that wasn't number 7, that was number 9. And then number 10 says that from 3 to 9 I have a parabolic equation. It wants me to write the equation of my parabola. So let's go ahead and do that. So I'm going to do number 10. First of all, the h and k, the vertex we know is 5, 6. And then I'm going to need to plug in a value to find that a. So y is going to equal x minus 5 squared plus 6, and then in here there was a stretchy factor, an a. So to find that a value, we're going to plug in any other point on my graph, and it looks like on the graph we could use 7, 4. So we're going to plug in 7 and 4 for our x and y values. So we're going to have y, oops, it's not right, y is 4. So 4 equals some a value. I'm going to plug my 7 in, and 7 minus 5 is 2, and 2 squared is 4, and then plus 6. So I'm going to subtract my 6 over, and I'm going to get negative 2 equals 4a, and so a is going to equal a negative 1/2. So we can write our equation. Y equals negative 1/2 x minus 5 squared plus 6. And then the last question, which I'm going to squeeze in on this page, it says, state the intervals for which h of t is less than 0. Well, if h of t is less than 0, it's below the x-axis. The graph is negative. And that happens from bracket 8.5, comma 9 bracket. And we used brackets oh, sorry, no, let me back up. This one is a parenthesis. If we're going to call that point 8.5, at 8.5 I equals 0. Well, this wants to know where am I less than 0. So right after 8.5, you are less than 0 till 9, and then the graph ends. So hopefully that helps you do page 45. This is a good page to review because it definitely is a good test-like problem. And now on the next page, we're going to go on and do the problems on page 46. So on page 46, it gives us a function, and it says that I have some function f of x, and it equals 3x squared minus 2x minus 5. It says graph a function and determine any relative maximum or minimum values, round to 3 decimal places if needed. List the intervals over which the graph is increasing, decreasing, and constant. So to graph this parabola, you have a couple different options. You can factor, you can find the two x-intercepts, you can use x equals negative b over 2a to find the x part of the vertex, and then plug it back in to find the y part of the vertex. You can use what I call, once you have the vertex, you can use the 1, 4, 9 pattern, but let's just kind of jump in. I'm going to actually just find my two x-intercepts, and then I'm going to find my vertex, then I should be able to make my parabola. So to find my two x-intercepts, I have to factor. I know one of your favorite math F words. So I'm going to use this method called A times C. So I take my A value times my C value, so 3 times negative 5 is negative 15. Now I need to find two factors of negative 15 that add up and make negative 2. Well, that's going to be 3 and negative 5. So now I can rewrite my equation 3x squared plus 3x minus 5x minus 5. And I just want you to note for a second, I haven't changed anything. Because when you combine like terms right here in this pink underline, you're going to get back to your negative 2x. So now what I'm going to do is I'm going to do factor by grouping. You take the first two terms and you make them a group. You're going to take the last two terms and you're going to make them a group. So in my green stuff, those two things have some stuff in common. And they have a 3 and an x in common, leaving me with an x plus 1. And then in my blue group, those two things both have a negative 5 in common. And so you have an x plus 1 left. Fun fact, I love math because it's very easy to tell whether you're right or wrong. It's got black and white. Yes, no. Well, I know that I factored properly when I use factor by grouping because the two things in the parentheses are the same. So if you look, this x plus 1 and this x plus 1 match. So I know that I factored successfully. So my final answer in factoring is going to be 3x minus 5 and then my x plus 1. So my two x-intercepts are going to be 5 over 3 comma 0 and negative 1, 0. And then I can also use x equals negative b over 2a to find my vertex. So it's going to be 2 over 6, which is a third. And then you're actually going to go in and find f of 1/3. You're going to plug 1/3 into the function in your calculator. And when you do that, you're going to get negative 16 thirds. So I'm going to go ahead, I'm going to zoom in real quick, and I'm going to graph everything that we have right now. So if I were to graph everything we have 1, 0 at negative 1, 0. We have another 0 at 5/3, 0, which is a little bit more than 1, but not quite 2. And then we also know that we have a vertex at a third, comma, negative 16 thirds, and negative 16 thirds is not quite 6, a little bit less than 6. It's bigger than 5, but less than 6, so right in here somewhere. And then from here, and again, I can't draw very well, but again from here, we can say that we have a beautiful parabola. So there's a beautiful parabola. Now if I want to go ahead and answer the questions that were asked of me, the questions were, where is this function increasing, decreasing, and where is it constant? So let's go ahead and answer those. So I'm increasing, I'm decreasing, and I'm constant. Well, the place that you're constant is pretty simple. It's going to be the vertex. Your constant at x equals 1/3. And we are going to decrease from negative infinity until that 1/3. And then we are going to increase from the 1/3 till we go to infinity. So there's our answers. Okay, so the last problem on page 46 is a lot easier to deal with only because it's already been factored for you. So it says that f of x equals x plus 4 x plus 2, and then x minus 2. So using the zero product property, we can set each one of these factors equal to 0, and we can simply graph what we have. So I'm going to go ahead and zoom in. And so we know that we have zeros at negative 4, negative 4, negative 2, and 2. And you can make a number line, you can plug in points. If I were you, honestly, at this point in your mathematical career, I would say that your best bet is to graph this in the calculator and copy it down. And so if you did that, you're going to get something like before I do that, I'm going to need to change the scale based on my calculator. So I'm going to change all of these scales. This is going to be a 4 and 8. So each one of these hash marks is going to be by 4s. So this would be a negative 4 down here. So that way my graph will fit so that you can see it. So your graph is going to look something like that. And let me go ahead and label these really important points. And all I did was trace these off my calculator. So this right here is negative 3.1 approximately 5.05. And that was a max. And this min over here is at 0.431, comma, negative 16.9. And then what I'm going to do is I'm going to zoom back out. And so if I want to tell someone where this one is increasing, decreasing, constant, increasing, decreasing, constant, you're going to, from negative infinity to, from negative infinity until my negative 3.1, we're going to increase. And then x equals negative 3.1. We're going to be constant, and then we're going to decrease from negative 3.1 until my 4.31, and then at I wrote that wrong, it should be 0.431, and then at 0.431 we're constant, and then we're going to increase again from my 0.431 till infinity. And there's your answer.